All right, class. So here we go. I'm going to go ahead and try to. I'm going to explain this how to use this lab because you're going to be having to use um, this PHET lab uh, simulation to answer questions later um, in the Nearpod. So here we go. So we're talking about Boyle's law. Okay, so Boyle's law has an inverse proportionality between the volume and the pressure. Okay, so what we want to do here is that, as you can see, that this box here is um, is going to be considered the space as to the volume. Okay, you can open it up, you can close it up. Okay, so it opens and closes. What we want to do here is, first thing we want to do is um, pump some molecules into this space. All right. So as you can see, the temperature here is 300 K at the top, right above this thermometer here. So we're at 300 K, which is Kelvin. K is Kelvin. Where you see here the pressure, see these numbers down here. That's going to be the pressure. It's going to be an ATM. ATM is atmospheres. All right, that is a unit of pressure. Um, Down here, you can see that we could heat it up and cool it down. But what we know about Boyle's law is that temperature is always going to stay constant. So we want to hit this temperature up here at the top. You want to hit this button here that says temperature to keep it constant at 300K. All right. So now we have, see how the bucket now you cannot turn it, you can't give it heat or cool it down. So what Boyle's law says is that whenever, let's say, volume gets bigger, and we can make volume bigger by bringing making the box bigger. All right. So Boyle's law says when volume gets bigger, pressure becomes smaller. Okay. And vice versa. That's why this is an inverse proportionality. If something happens to one side, the opposite happens to the other side. Okay, so when something happens to one of the variables, in this case volume, the opposite is going to happen to the pressure. Okay, so here we go again. Here's another example. So as volume gets smaller, okay, and we close the box, you can see how the pressure becomes higher, becomes greater. So as volume gets smaller, see how the box is now smaller, pressure becomes bigger. All right. So let's do that again. So let's open it up again. So as volume gets larger, see how the pressure here got smaller? All right. And that's because there's a lot more space for these molecules to move around, not creating so much pressure, because it takes a little longer for them to hit the sides of this canister. All right. Now, when you bring it closer together, when you close the space or the volume and it becomes smaller, the frequency in which these molecules hit the side of these bucks and each other creates more pressure. Okay? So, with Boyle's law, again, at constant temperature, okay, if volume becomes smaller, pressure becomes higher. Again, at a constant temperature, when volume becomes bigger, pressure becomes smaller. And that basically is Boyle's law. Okay, so here you this is just a video. I'm gonna give you a chance to um, play around with this. Okay, um, there's some other stuff that you can do. You can, so I just went over like Boyle's law. All right. The other things you can do with this is that you could put nothing. See how it says nothing up here? Like nothing's going to be held constant. All right. um, some things that you should really look out for. You can put you could put some more molecules in here. All right. Um, Most of y'all are gonna do this because I know you will. But you can put a lot of heat on here. See how the temperature at the top, the K, the temperature is rising. Okay, so as temperature starts to rise, and you can just think about, throwing like a Coke can in a fire or heating it up somehow. The molecules on the inside of that Coke can will start to move around like this very fast as the temperature goes up, right? So eventually, when it gets to a certain point, okay, see how the pressure is rising over here? So as the molecules smash into each other at this certain temperature, what ends up happening is the pressure starts to build up on the inside. And that just kind of makes sense. And so when it gets to a certain point that the box can't hold it anymore, the lid, of course, the 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 lid blows off, right? And so as you can see, um, the all the when the lid blows up, all the gas escapes, the temperature starts to go down. Um, you know, the pressure on the inside starts to fall. Okay, so this is indicative of how anything can happen. Like it could be like a can of hairspray. It can be anything that has pressure on it. Anything that's a closed system, and you put heat to it, the molecules on the inside will um, will heat up, start smashing against each other really fast, building up pressure, and then eventually it's going to explode. You can come down to this little deal right here, this little orange reset button, and reset it all. Okay, so you can play with this. All right, um, you can even see that if you were to, and this, remember, this is all not, there's no constants here. But when you do Boyle's law and I start asking you questions, you're gonna have to hit the temperature, okay, to turn it off, uh, turn off the temperature, okay, so that way you won't be using the fire or the ice cubes. So if we put it on nothing, and this is just playing around with it, right? So you can also see that when you bring down the temperature in this closed system, okay, um, notice how the molecules start to move really, really slow. Okay, and so this is pretty much the way things work. If you get a soda can or and you cool it down, the molecules on the inside don't smash up against each other as much, and the pressure goes down very significantly. All right. So, like I said, you can mess around with this, but whenever we're doing Boyle's law, just and you're answering the questions, you have to pump it once. That's all you're going to do, and then you're going to hit the temperature so you can keep it constant, and then start answering the questions. All right, so I hope you understand how to use this. If you have any questions, you can email me, and I'll answer for you. Also, I'm on Zoom Mondays and Thursdays from 1 p.m. to 2 p.m. Um, just come in, ask questions, or if you want to say hi, that'll be great too. All right, see y'all later.